That's right. Uh, Today we are going to execute program number two. Write a simple facts for the statements and querying it. So what we have to do? So we have to define some facts. For what are the facts we are defining? According to that, for using that, we have to write a queries for that. So how that facts will work and what are the query statement we have to use. So that is a program. So first we'll see some preliminary basics. So that is what exactly that Prolog and how it works. So Prolog query works by pattern matching. So we heard and we also know the pattern matching concept in the Linux-based platforms and what you call the Linux operating system. And if you come to the some of the programming languages, there also will see the pattern matching, right? The pattern which exists exactly with the available data, so then only it will give the respective output like a true or false or what based on the what are the pattern we are submitting, right? So here in the prologue also, whenever we are writing a queries, how it works, works based on the pattern matching. If that pattern is exists, then only it will give the results like a true, or it will display the results. Otherwise, it will display false or no. So the query pattern is called a goal. So why we have to call it goal? So we want to execute, we want to get some output, right? We want to get some data. So for that, what we have to do, we have to set up the goal. To set up the goal, what we have to do, we will write the Prolog queries. If there is a fact that matches the goal, then then the query succeeds and the listener respond to the yes. So here the concept is whenever the data exists or whenever the data match with the pattern what we are sending through the query, so then it will give the input as a output as a yes, nothing but yes, it will give a output as a yes. Otherwise, whatever the data is available, whatever the pattern is matched, so that data it will display. So that is the information what here we have. So that is what if there is a fact, yes, if there is a fact section, so then if it matches with the goal, whatever the goal we are setting, nothing but whatever the query we are writing, so then it will respond as a yes, nothing but it will return the value what exactly the pattern have been, or in some cases, it will respond yes if it's just only a single pattern. If there is no matching found, so then the query fails. It will say no or false. So the output whenever the pattern is not matched, it will return output as a no or a false. No or a false. So here the mainly what we are going through the Prolog query will work based on the pattern matching, and that is what we call the goal. The pattern what we call the goal. If the goal matches with the pattern with the available knowledge base, then it will respond as a yes, or the respective data will display or information will display. If the data does not matches, the pattern does not matches, or the goal does not matches or not succeeded, it will return as a false or a no. So this is what the fact and the respective statement. And this Prolog's pattern matching is called unification. So this Prolog's pattern matching is called unification. So in which cases where logic base contains only the facts, unification succeeds if the following three conditions hold. So whenever we are using this unification concept, it must hold the three respective conditions. That is what the predicate named in the goal and logic base are the same. So whenever you define the respective goal, right, whatever the logic base you're defining, that should be same. For example, in previous program, in previous program we taken the variables, right, and we taken the rules. In the rules we taken like likes Jai comma Malika, likes Jai comma Malika. So Jai likes Malika. So likes is nothing but the rule what we have. So that respective predicate name has to be used in my query also. Then only it will give the information. That is what the predicate name in a goal as well as the logic base should be same. Both predicates have the same arity. The both predicates have the same arity, right? So whatever the number of arguments they have, so that should be equal when you are giving the query, and all arguments are the same. So if you have the one argument, if you have the three argument, if you have the two arguments, or if you don't have the argument at all, so like that you have to write the query. So this is the basic information what we have about the facts and how we have to do the query. So in this program, so here whatever the whatever the highlight no, so that is a program and respective explanation are there, so that will go through the document. To go through the document, now what I will do, I'll go to the online compiler, so that will be easy for us also instead of I'm going to the GNU. So this is already I written, so that is what write a simple facts for the statement and querying it, right? So now what I'm doing here, I written some facts. Here I written some facts with the predicate. So here, if you place a cursor, it will show it's a predicate. So this is the respective argument. The kitchen is the argument. Office is the argument. Hall is the argument. Suppose when you have the two more than one word, so that is respective words we have to quote it. That is what we call the atom. So what I explained in the class, right? So the same atom we have to use dining, space, room. So more than one word if you have, we have to enclose with the single quotes like seller. So this is another argument. So I have a predicate called room. So for room, room, kitchen, room, office, room, hall, room, dining room, room, cellar, right? So this is the one example which I'm taking as a room as one of the predicates. Similarly, I have the door. It contains the two arguments like office, hall. Office, office contains the door hall. Office contains the door hall, like door, kitchen, office, door, hall, dining room, door, kitchen, cellar, door, dining room, kitchen. So this is another predicate. So next another predicate we have with the two arguments. So location, desk, office, location, apple, kitchen, location, flashlight, desk, and so on. And I have the edible, like one more predicate with the argument called apple, edible, crackers, uh, taste, techie, so bronchily. So here all the respective facts are ended with the full stop. All the predicates are ended with the full stop. Now I'll come to the prompt. So here in the right hand side, I'm taking the prompt. Now I'll write the query. Right? What is the query condition? So we have to use the same predicates which we use. Right? So this is how we have to use room of what? So kitchen. So if you write like this, so if you then you run here at the bottom, so it will show true. Room is room of kitchen. It exists in my knowledge base. Yes, the kitchen exists in my knowledge base. Similarly, for office. Similarly, for the office, when I run this one, yes, office exists too. For example, if I give office one, if I run, see sorry, it's giving the false in the sense office one does not exist here, just only the office exists, right? So this is how my knowledge base will work. This is the pattern. So this is my pattern exactly. It will match with the existing knowledge base. If the data exists in my respective fact along with the arguments, then it will return true. Otherwise, it will return false, right? So instead of taking this one by one, what I'm taking the variable called x, room x here, room, kitchen, room, office, room, hall, room, dining room, room, cellar. Suppose individually I'm taking like this room, kitchen, five times I have to execute room, office, room, hall, dining room, and cellar. So now what I'm taking the variable. When I execute the variable, see one time it's showing kitchen. If I click next, office will come. If I click next, hall, next dining room, then cellar. So five arguments what I have, so that get executed at the end, right? So all five values are displayed. All five values are displayed. This is wrong. Again, I will execute once. So this is what one by one we shown, right? Suppose if we click 10, so all five will come. Why I am taking 10? Again, I will show. Here we have 10, 100,000 and stop, right? So one 10 indicates is a bunch wise it will come. It is a bunch wise it will come. So for example, if I more than or 10, up to 10 it will take. If we have less than 100, so all 100 values will be comes under a single shot. Instead of clicking the next, if I click on 100, even though I click as 100, so whatever the values are available for the respective fact, so that respective fact will get executed. So this is how we have to write a query to get a results either true or false or with the help of variable to get the information. Now I'll write one more query, that is what door. So door, office, comma, all. See, I can use the full stop also. So now it will run true. Yes. Door, office, all exist. Yes, it exists in my knowledge base. This is entire what we call the knowledge base system. In this knowledge base system, what are the query I'm writing? So according to that query, it will return true or false. If the data exists, it will return true. If the data does not exist, it will return false. Now, so if I make it like hall, double three. So if I execute this one, I'll get answer as a false because office exists, but all does not exist. All does not exist. So what I'll do, I'll remove this one and I'll fill with the variable x comma y x comma y. So I will run this one. So I will get hall office. Why? two times one by one I'm getting here. I have a x as a one of the argument, y as a one of the arguments here. Office x, office hall y, like two arguments I have. So if I click next, next set of xy value will come. Second, third set of xy value, fourth set of xy value, fifth set of xy value. So then it is aborted. Again, I will execute the same. So instead of using next, I'll click, I have here one, 2, 3, 4, 5, only 5. So 10 is enough. When I click 10, all respective 5 set of values will appear here. So this is how we have to execute the arguments by based on the respective variables. So I'll show one more example. This is the uppercase. These two are uppercase. Now what I'll do, I'll go with the lowercase x comma y x comma y. So when I run, it will show false because always variables start with the upper cases. Always variable start with the upper cases. That is the condition. Even if you one variable is in uppercase, another in the lower case also, if you run, it will give the error. So both variables should be in the uppercase format. Uppercase format. So when you run, you will get it. So all thousand, I'll just click what are the data values available so that it will check. Right. So next, this is another example how we have to do the querying. So I'm using the online compiler like a Swish. You can use that one also. You can go with the GL. So it's very easy. So that's why I'm using. So next I'll go to the location of desk, comma office. Okay, I'll run. Yes, true. It's exist. Desk, comma office exist. So desk one, comma office false because disk one does not exist. Similarly, what I'll give x and I'll give y. So run. So one set of value, second set of value Apple kitchen, flashlight desk, washing machine and cellar, and nani and washing machine, broccoli kitchen, crackers kitchen, computer office. So these are the set of values what we have in the location. So in this respective predicate, if I want only a particular data, I have to give that arguments. If I want all the data, just I'll replace with the variable called x and y, then I'll execute. So when I execute, all values will become. So I'll click 100. So whatever the values are available with the x variable and y variable, that will get listed. So in my knowledge base, these are the values which is available. Similarly, like we have edible of x. So instead of apple here, what I'm doing, I'm taking directly x, run, yes, x equals apple. Variable. If you want to know what value assigned to that variable, so in my knowledge base, what is the argument available for the facts? So that becomes an answer for here. Answer for here. So if you take apple, it will return true because that is exist. So instead of lowercase a, if you take uppercase, apple equals apple. Why apple equals apples? Uppercase a become a variable here. Apple, this is a variable. Small case apple, this is a value, this is the argument. So that is the differences where we have all the variable first character start with the upper cases. That is very important. Similarly for tasty key, if you want to know what is that tasty key, right? So I'll run it. So yes, it's a broccoli. It's a broccoli. It's a broccoli, right? So this is how we have to use. We have to use the simple facts, and the based on the fact keyword, we have to use. We have to start the queries by. Suppose if I want general information, I'll go with the variable. If I want the specific information, if I want the specific information, what I will do that I will use as it is. So right, yes, true, it is there. So if I am checking only broccoli, but if I want to know what are the other options available, that I'll get it. So here Bronco is only one. So if I go back like location x comma y, location x comma y. So right, so run. So first option is come. If you want to know at a stretch, so all will come. Right. So instead of this, if you take desktop or if you take Apple and kitchen instead of a variables, it will check only this particular fact with the whatever the argument I'm passing. This is a specific one. This is a specific one. So this is a general one. This is a general one. So like this, we have to write the facts. We have to define the facts with the variables, and the same fact name we have to facts name we have to use to write a query. So this is the program. That is what write a write a program, write a simple facts for the statement and querying it. I hope it understand. Thank you.